Alrighty, guys. Here we go with, excuse me, with functions continued. So you can see I'm starting you off here with here's the assignment I want you to do. You'll notice some of these are composites, but then some of these are unique. We haven't talked about adding, subtracting, multiplying, or dividing functions. Also, I gave you a couple triples, like number 27 here. That means I'm going to plug S into G, and then I'm going to take that result and plug that into H. Oh yeah, you can do that. You could plug as many functions in, compose them as much as you want. But anyway, I'm going to get rid of that line. Please pause it, take a picture of it, and here's the answer key. Pause it, take a picture of it. I did not have any whiteout, so when I wrote down stuff, you'll see a couple scratch outs, like here on number 30. I scratched that one out. I made a boo-boo. I wrote a +5 here. I meant to write a -3. And there you go. So take a picture of it. All right. Let me show you what I'm going to do. I have to show you how to do this. So for the examples I'm about to do, for the ones that I'm about to create here, I'm going to use these functions. They're similar to the ones on the assignment, but please don't get them confused. I'm going to use these ones here for my examples. So let's pick up where we left off. So something like this, f of g of x now gets a little gnarlier depending on what they do to me with the function, because f of g of x means I'm going to take g and plug it into f. So if I were to do that, I would end up with 2x plus 4 being squared. Because what does f do for a living? The function f takes whatever you give it, squares it, then says -3 times it, and then takes away 10 at the end. So, just a reminder, you can never drop it like it's hot, that's a bad idea. It's not true. This is code for you're going to have to FOIL. So I'm going to write this one out, but I'm leading to something here. So I'm going to FOIL this, and really foiling isn't the worst thing that happens to us. We get what? 4x squared. There's going to be 8x and another 8x. So what is that? 16x. And then 4 times 4, that's 16. And then over here, I got to distribute a little bit. So I got -6x minus 12 minus 10 more, because that guy is still part of the picture. Let's combine some like terms, and lo and behold, I will get 4x squared as my leading term. Highest power should go first, let's be polite. Then I will have 16x's, take away 6x's, that would give me 10x's. And then 16, take away 12, take away 10, would be a fancy way to say -6. That would be the name of f of g of x. Now do me a favor. I'm trying to teach you as we go to be polite with mathematics. When you are composing functions, you do whatever happens to be the indicated operation in the problem. You will get your answer when you write it in descending order, etc. But here's what I wanted to point out. There is a GCF of 2 in here, but they are not. The instructions were not factor. The instructions were evaluate the functions. So do not take out the GCF. You only do that if they ask you to factor. Now, that's the answer. That's done. Hooray. But here's where we're going today. FGX. Now, do not get these two things confused. FGX means, guess what? F times G of X. F times g of x. So this time I'm going to be multiplying the two functions. Now, just a word to the wise, I'm going to have to then put this in parentheses because this guy and this guy, when we multiply it, we've got all kinds of jazz to go through here. Now, a trinomial times a binomial, or a binomial times a trinomial, I'm going to scroll down a little bit, guys. Well, here we go. If I wanted to, I could think of it this way, that times that, that's working. I'd get 2x third, and then plus 4x squared. But then I'd have to do this piece of the puzzle. I'd say minus 3x times that, so I get negative 6x squared, and then minus 12x. And then last but not least, I would get minus 20x and minus 40, or negative 40. I combine the terms, I get it in the right order. But remember, multiplication, the order does not matter. FGX is the same as GFX. When you multiply, it doesn't matter. But I'm trying to get to this point. G of f of x is not necessarily the same thing as this dude. When you're composing functions, they can equal each other, depending, like if the order is reversed, but that is only rare. Very rare does that happen, and that will be discussed in our next lesson, not this one. However, when you multiply, the order doesn't matter. Remember, just like regular numbers, 5 times 2 is 10. 2 times 5 is 10, so you're going to get the same thing. Now, the other thing is, look at the difference. There's parentheses here. There's not parentheses here. So don't get a composite and a multiply problem mixed up. But the reason I'm saying that is I normally multiply functions that have a binomial and a trinomial. When I do the multiplication, I usually think of it this way mentally. It's easier for me. But I would still end up with the same exact terms. I would. So how do we be polite mathematically? We write them in descending order. This guy is the highest power. He goes first. No matter which way. 4x squared, take away 6x squared, that's minus 2x squared. And then let's put these parts together. What's that? Minus 12x minus 20 more is negative 32x, and then minus 40. And this would be called FG of x. So I'm multiplying it. Now let me ask you, do you see the GCF in that thing? Yeah, there's a 2, but don't take it out. They did not ask you to factor. They asked you to evaluate functions. Now, once again, if you create a function, FGX, and they say, what is FG negative 1? You can do the same thing you did before. You could plug the negative 1 in to your new function and see what the result is. That's totally legit. That's okay. You could do it that way. Or you could take that negative 1 and plug it into the f function, see what that answer is, and then multiply that times whatever the g function is. Either way, you could come up with the correct numerical answer. Now, I just wanted to make this point. I'm going to scroll up to the top. I'll be back, don't worry. So if you look at my practice sheet, I did GSX, like G times S. So if I did G times S, and then they asked me something like, see at number 14, what is GS5? I could take my answer from number 12 and plug 5 into it, or I could plug a 5 into here separately, and I could plug a 5 into here separately, and then multiply the two together. So when they write GSX, or as I wrote on the worksheet, GS x. They could also write, and I know it gets confusing sometimes because there's different ways you can write the same thing. These are all equivalent statements in mathematics. They would all represent the same exact statement. So, if GS of 5 is the question, and you think it's easier to plug the 5 into that one separately, then plug the 5 into that one separately and multiply, hey, that means you did it that way. That's your choice. Go for it. It's, either way you slice it, it's the same answer. These are also equivalent statements. Now, I'm not going to go through that with every single question because look at number 3. What do I have you do? F plus G of X. And then what do I have you do the very next one? F plus G of 2. Yeah. So we spent a lot of time in the last lesson. So there's some things I really don't have to go a ton of depth into for you. But I do want to point out you can add, subtract, multiply, divide. So let's go back to what I did. Here we go. Once again, I made up these functions here. Let me box these. Come on. There we go. I made up these functions here. Oh, crappy box. For us to practice with for the examples. But number 1, don't get composite confused with multiply, because that's one super big boo-boo people make. Now, these functions, again, I'm going to use them. Here's another thing I want you to watch out for. So I'm just pointing out some things, and hopefully after the last video, this one's like, oh, this isn't that bad. That's what I'm hoping. So here we go. I'm going to do something like this. I'm going to do f plus h of x. Now, my f function that I had up above is this guy. My h function up above is this guy. So f plus h of x, you got it. It could be written like this. It totally could. You could write it the same way. What does it mean? Add the two functions together. So if I were to do that, it's just fancy talk for I've got this guy plus this guy. And you guessed it, I'm going to combine like terms. I'm going to write it in descending order, so those two dudes go together. That's 2x squared. Minus 3x is all by itself, so it goes next. And then negative 10 minus 3 more is negative 13, and that guy would be the answer for, you guessed it, f plus h of x here. Did I say g? I think. Anyway, f plus h. So, just for kicks, if somebody said, what is f plus h of 3? I have the choice. I could take the 3 and plug it in here and get this answer. I could plug it in here and get this answer and add the two answers together. I could do that. Or I could just jump right down to this dude and say, you know what? I think it's less work for me this time to just plug the 3 in there. Because if I do, I'll get, for the first part, 3 squared is 9. 9 times 2, that's 18. Minus, here it would just be 3 times 3, so that's 9. And then take away 13 more. So to me, if I wanted to find f plus h of 3, this time using my function I think is a faster route. And what do I end up with? Negative 4, and I go, cool, and I'm done. Now, multiply, not too bad. Add, not too bad. In fact, subtract's not too bad either. It's not. Let's see. I have f and h right there, so what the heck? I'm going to do this. We'll do it in reverse. We'll do this one. H minus f of x. You guessed it. This could be written like this. H of x minus f of x. It could be. It could be written either way. Remember, this is just shorthand. In math, we like to condense our statements down because we don't want to write out a huge sentence to explain what we're doing. We all know the same notation. So here we go. h minus f. Well, h says this. H says, I am h. I am going to take away this guy. But here is where people mess up. If I'm taking away all of f, that means the whole thing is getting taken away. So I don't want to forget parentheses. This is h taking away f completely. So the negative gets distributed. It's like having a little -1 out front getting distributed. So what do we end up with? Well, let's finish it off. We get x squared minus 3 minus x squared, then plus 3x because it's a sign change, and plus 10. So what do? I'm going to knock you out. Mama said knock you out. And then I get 3x. And then this dude and that dude, I get 7. So, once again, h minus f of, let's say, -4. Hey, I would totally plug it in here and just say that's going to be 3 times -4 plus 7 more. And I would say my answer is -5. I'd be done. I'd be home. I'd be eating cornflakes while somebody else is still working, because that would be the faster way to go. So, before I get to division, I want to show you this. When you do the homework, do it in the order I put it on the paper. So, like if you do problem number 3, that I already checkmarked here, you do problem 3, then you have a choice when you do number 4. Do you want to plug the 2 into f and the g separately, or do you want to use your function? Same thing, like number 5. If you do problem number 5, then you have a choice on number 6, etc., etc. I'm trying to make your life easier, not more difficult. So, long story short, we have just division to kind of play with here. So let me bring you to division. Division can be super easy or a pain in the butt. So I'm going to use these functions again. I am. And there is one combination here that I would not give you yet for division because it's in our next unit, so I wouldn't teach it to you yet. So let this be known. If I have not really shown you how to do something, it's not fair game on an exam. It's not. But if I do show you how to do something, hey, anything goes then. That's, if it's been shown to you, you should know it. But here's the deal. I am going to show you guys how to do f divided by g. That's my first one. But I would not do g divided by j, because that would result in a double fraction with variables. So I would not, this would not be on the table right now. G divided by j of x. I would not do that. That would be in the next unit. So don't worry about, if you run into something that like, what? This is crazy. That wouldn't be on this test. Okay. Here we go. I'm going to do, whoop. God, I hate when I do that. This thing drives me nuts. I wish I had a classroom sometimes. Okay, so here's what I'm going to do. I'm going to do f divided by g, and I think I put it in parentheses in the worksheet. And here we go. So what does f do for a living? F looks like this. What does g do for a living? G looks like this. Now, you might go, hey, cool, I'm done. Or you might be a rule breaker and say, you know what? 2 goes into 10 5 times, and x can cancel x. If you do that, you did not do the summer packet, because there was a section that had you do simplification with these type of things. Don't make up your own rules. Now, I personally believe that this was one of the worksheets that you guys had to do in the summer packet that was the toughest. But do not make up your own rules in mathematics. Here's the one thing I'm going to tell you for sure. Let me get rid of all these marks that I put on my stuff. This is a trinomial. This is a binomial. Trinomials do not pick on binomials. So what do I do? Well, I'm either done or I can factor and cancel, meaning I can reduce. Why do I think that way? Because fractions can reduce sometimes. So let me show you what I'm talking about. In the top part, I am always suspicious of trinomials because sometimes they break up into two binomials. I don't know, but I'm going to dink with it. X times x, that would be how I'd get x squared. In order to generate a negative 10, I could have a positive times a negative. But what goes into 10? Well, it's either 1 times 10 or it's 2 times 5. And in this case, hey, guess what? If that was a 2 and that was a 5, the top part would factor. Now, take a look at this guy. I'm also extremely suspicious whenever I see a GCF, because I could take a 2 out of the bottom, and then I'd get this. And this was that one worksheet in the summer packet where I could then reduce this because a binomial can reduce a binomial. Trinomials don't pick on binomials. Single numbers don't pick on binomials, whatever. When they match exactly, you get to knock them out. So what's left in the top? X minus 5. What's left in the bottom? 2. Coolio. Now, do they always reduce? No, they don't. I'm going to do this one because I wanted to make sure that you saw one that is like trying to get you to do something with it when there's really not much to do. So let's try f divided by h. Once again, this is what my f function looks like. My h function from up above looked like this. Okay, let's recap what we just did. The top part is a trinomial, the bottom part is a binomial. Do they match exactly? No. So you don't get to try and reduce anything unless the top part would factor, and we already know it does. It factors to look like this. It does. But does that match exactly with this? No, because it's not in parentheses. Okay, how about now? Does it match with... No, it doesn't. So this answer is done. You plugged in this guy, you plugged in that guy, guess what? You're done. What if I factored it? It's still the same answer, and it's still done. You can't do anything with it. Sometimes when you do a division problem, they're extremely easy because you're stuck. You can't do anything about what you've got. And then sometimes you got to be on the lookout for something that would reduce. Word to the wise. Now, here is something I showed you before, and this is fair game. So I'm not going to mess with this guy. I'm not going to mess with, hang on, this one. Let's just focus on this guy up here. What if I gave you f of g of, something like 6? That would be a pretty easy question, because you just wrote this function. And guess what? It'd be so easy to plug a 6 in right there. 6 minus 5 is 1. 1/2. My answer would be 1/2. Okay? That's easy peasy. But what if I gave you something a little more icky looking, like this? What if I said, find f of g of 3 1/2? Now that looks worse. Because if I plug 3 1/2 in, I go 3 1/2. I'm going to do the work down here, guys, because I'm running out of room, so I'm going to scroll up a bit. So, if I did 3 1/2 minus 5, that's in the top, divided by 2, I would say, 3 1/2, take away 5. Well, that's not the worst thing I've ever seen in my life. I think it's negative 1 1/2. You can check me on a calculator if you want. But then I have negative 1 1/2 over 2. This is a double fraction, but it's numerical. You should know how to interpret this. In fact, the top number up here, I could rewrite it and say that is the same thing as negative 3/2. And then I could say divided by 2. That's totally legit. What did they teach us in the 4th grade? They taught us to flip and multiply. So the final answer for this thing would be negative 3/4, it looks like. That would be this answer here. So that's fair game. I just want to remind you, if you ever give me an answer that has a fraction inside of your fraction, it means you did not simplify it enough. Every double fraction can be written as a regular fraction. Okay, let's talk about the last one that I want to make sure you get. Okay, so let's do this. I am going to do a triple composite because you've seen everything that you need to worry about now. And I'm going to do G of J of H. See, last lesson we talked about composites. You can compose as many functions as you want to in a row. You totally can. But, you know, I'm not going to go past a triple. This is a triple. You know, in calculus you'll run into triples. But, you know, usually you try to figure out a way to make it a double. Anyway, let's do this. What does this actually mean? It means take the h function. We're going to work from the innermost parenthesis outward. So, if I did g of j of h of x, which, by the way, is fun to say, that means I'm going to take x squared minus 3, and I'm going to plug it into j. So what does j do for a living? J takes whatever you give it and puts this guy in the bottom, and then says plus 2 times this guy. That's what it does. So, I'm going through this because I want to make sure that we are polite. And this is a gnarly one. This one, because I got to clean this up a little bit. I go, okay, so I have, what do I have? I have 4 over x squared minus 3. Oh, that's a horrible looking squared. That's really ugly. There, that's prettier. Plus, what happened over here? 2x squareds minus 6. But see, here's the thing. This and this, they don't have denominators that are the same as the other guy. When you have information like this, you need to get common denominators for me. So, what is the... I'm going to use a color here. Let's try blue. Blue. Come on. This guy does not have the same denominator, so I'm going to have to give it to him. So I give it to the top. When you change the bottom, you change the top. This guy needs this denominator, so I got to change the top. See, I want common denominators on my answers. I will always give my answers with common denominators. So let me go back to black pen, and I'm going to scroll down a little bit. So this is at the top of our page. And let me break this down for you. If I do give this guy the same denominator, this guy, what happens is the denominator that I have now is this, all the way across the board. But what's in my numerator? Let's do this over here. I'm going to do it separately. What is actually in my numerator? Well, I have a 4. And then I have plus 2x squared times this. Oh, so I'm going to end up with 2x to the 4th. You guessed it. 2x squared times x squared is 2x 4th. Minus 6x squared. And then I got to do this piece. And the minus goes with the 6. So I get minus 6x squared again. And then what do we get? Plus 18. Let's put this together in the correct order. This guy goes first. This guy goes second. And then the last dude, that's 22. Whoops, 22. And I'm not even done yet. Why am I not done yet? Because this is just what happens when you take H and plug it into J. I got to take this stuff and plug it into G. But lucky for me, What does G do? See, I did H into J. I've done that much. Now I got to take this result, this whole thing here, and plug it into G. And what does G do for a living? Well, G, if you forgot, is my function that I made up earlier that looks like this. So we're almost home free. It's ugly looking. In fact, the one on the worksheet is not even close to this nasty. But G would then take what I have here, multiply it by 2, and add 4 to it. So if I was to multiply everything by 2, remember it's fraction multiplication, so I put a 1 on the bottom, and I make it look like a fraction. So in the bottom, I have 1 times x squared minus 3, so I get x squared minus 3. In the top, I get 2 times all this stuff, and I get 4x4 minus 24x squared plus 44 plus 4, and then once again we're stuck with this polite mathematics thing. That's got a 1 on the bottom. I need a common denominator, and that's why this one is super evil. When you do the practice problems, you'll have to get a common denominator on one, but it's nowhere near as nasty until it needs to be, and that'll be in Unit 3. Don't worry, I'm not going to kill you with algebra. This guy would need to have the same denominator, so if I change the bottom, I change the top. And then everybody has the same denominator. Let's go back and finish this baby up. And remember, you can pause it, you can re-watch it, you can do whatever. I need to clean this up so the numerator's clean. But what's in the bottom? That's what's in the bottom. Totally. And what would I get then? In my numerator, what would my numerator look like? Well, I have this information here. I do. And I'm going to add it to, well, let's distribute 4x squared. And then minus 12, it looks like. And let's combine like terms. So highest power goes first. I am first. Then, minus 24x plus 4x gives me minus 20x squared. And then, last but not least, I have 44. Take away 12, because those are numerical pieces that I can combine there. And what is that, 32? Yeah, 32. And remember, they did not tell me to factor this. They didn't tell me, so you don't have to worry about pulling out a GCF and trying to do anything. But see this? That guy's name would be G of J of H of X. Worst type of problem you will ever see is when you have to get common denominators. But let me tell you, rest assured, look up here at my answer key. Ah, it went too far. I'd be suspicious here, because that might be one of those type of problems or something. Let's see. I'm just guessing. I don't remember. I don't have my worksheet memorized. Number 22. Is that a triple? No, it's not even a triple. Here's my first triple. Let's see what 26 and 27 look like. Oh, 26 and 27. My triple composites, I didn't even make you get a gnarly, super gnar common denominator. So, rest assured, this is where we're headed. But just wanted to give you a rundown of getting common denominators, putting things together. Don't factor unless they tell you to, unless it's going to reduce. Now, this one is not going to reduce because this guy's fourth power, that guy's second, that's a trinomial, that's a binomial. There's not even a GCF in the bottom. So don't worry about this one as far as trying to reduce it. But, you know, this would be fair game. I would expect you should see something like that. Based on what you had to do in the summer packet, this is fair game. This type of reduction here, but not the other one. Okay, so guys, once again, answer key, take a picture of it. There's the homework, there's the practice problems. Take a picture of it. then you don't have to keep staring at at YouTube. And then when you're done, take a picture of it and submit it. All right. Have a good one.